Hi, I will continue the session of classification of signals, and in this session we're going to explain energy and power signals. To classify the signals according to energy and power, we should be able to calculate the power and energy for signal. This process can be done for both continuous time signal and discrete time signal. In this session we'll focus on continuous time signal. So why we want to do that? It just will be indication for the strength or the largeness of the entity of a signal. How to calculate the energy of a signal or total energy of a signal? You get the signal x of t, and the signal here it means could be current, could be voltage, could be anything, and then find the amplitude, and then you square it, integrate from negative infinity to infinity. So that's how you get the energy. How you find the power? It will be similar to this process that you are going to square the magnitude of the signal itself and integrate it, but you don't integrate from negative infinity to infinity. No, you integrate from negative t over 2 to positive t over 2. Remember, t is not the period because we are not saying it's a periodic signal. It's a general signal. Just you pick any t over 2 from negative to positive, and then after the integration, divide it by t and do the limit when t go to infinity. That will be the average power of a signal. But if it's a periodic signal, we have a special formula for calculating the average power of periodic signal. We'll do the same thing, but the integration will be over the period, which we'll call it T naught, to distinguish between T naught and this T. This is general, but this T naught is the period of a signal, and divided by 1 over T naught, and there is no limit. Then what's happened? After you find the energy and the power, you got conditions. If the energy they calculated is less than infinity, it means it's definite value. In this case, the signal will be called energy signal. And by the way, once the energy is limited or is not infinity or finite, you'll find that the power is equal 0. But if you found out that the energy is infinite and the power is not infinite, means finite, has definite value, like 100, so you call it power signal. So simply you just can say energy signal has finite value of energy. Power signal has finite power of power. What about of nothing? If the energy is infinity, the power infinity, it's neither energy signal, neither power signal. Okay. So that's the condition we're going to do. All right. So you check the energy and see if it's less than, it's finite. It's finite, it's energy signal. The power, finite, power, it's a power signal. Just simple as it is. If it's not finite of the energy, not finite of the power, so it's not energy signal nor power signal. It was observed that most periodic signals are power signals. Okay, so when we try to check, just check the power formula. Don't go through both of them. It's better also to have like a numerical example. Just let's take a numerical example. But before that, let's just get something here. When you have a ramp function, obviously the magnitude is increasing indefinitely. You expect that the energy will be infinite and the power be infinite. So this signal will be like, it's neither energy signal, neither power signal. Something like that, decay exponential. So it has limited energy because it's decreasing, decaying. So we observe that can be energy signal. And this is a periodic signal, and we'll find that the power is limited, has finite value, so that's a power signal. But how can you prove it? How can we prove that? Okay, we have here 3 different examples. We'll take the first one. X of t is equal to e bar negative 2t for t greater than 0. I'd like to sketch it just to have feeling of it. That's t, and that's x of t. When and it's defined for t greater than 0, it means 0 before that. When t equals 0, it's equal 1 and be decaying. That's e to the power of negative t, and defined from 0 up to infinity. First, I find the magnitude. Since it's a real value, there's no complex or imaginary part, it will be the same. It will be -2. And then you square it. Okay, so e power -2 square, that's e to the power -40. All right. Then, well, according to the formula of the energy, we're going to integrate it from -infinity to infinity, x of t squared dt. All right. So we'll have, yeah, but it's not defined from -infinity, it's defined from 0. So I'll say from 0 to infinity. And x squared, it's e power -40 dt. That's equal to e to the power -40 divided by -4, integration from 0 to infinity. So I can say it's equal 1/4 e power -40. And since I got rid of the negative sign, I can change the limit, just flip it, be from infinity to 0. So e will be equal to 1/4. Then start to substitute. E power 0 is equal 1 minus e power minus for infinity, e power minus infinity is equal 0. So the answer is 1/4. So the energy is limited. The energy is finite number. It's less than infinity. So you don't have to find that expression for power. It's an energy signal. Why it's an energy signal? Because when we calculate the energy, we found it's finite. It's not infinite. Well, the second example here, we have a periodic function. So we're going to use the power formula for the periodic. Well, let's find the period here. T0, what's T0, the period? If we say, for example, we start from -2, you have 1 square, and then you'll continue, and then you're going to be repeated again. So from -2 to 2, and then from 2 to 6. So you can say that the period is equal to 4 plus 4, that's equal 8, right? From -2 to it's equal 8 seconds. So that's the period. All right. And the value is equal 5 between -2 and 2, and 0 from 2 to 6. Well, what is the formula for the power? Somebody might ask, I mean, why don't you use the energy formula? I said, okay, you can use the energy formula, you find infinity, and then you go to the power to do it. But we said before, periodic signal, most probably, it will be power signal, the periodic one. So we'll try this one. If it is true, we stop and we say it's power signal. If not, if we found the power is equal infinity, then we go and use the energy formula, okay? All right. So for periodic, the average power for periodic function is equal 1 over T0, the integration over the period for the signal square. Well, in this case, 1 over 8, and the integration over one period, you can say from -2 up to 6, that's the whole period, right? From -2 to 6, and x of t square dt. Let's make it a little bit in more detail. 1 over 8, and from -2 to 2, yes, 5, from 2 to 6 equals 0. So just I will integrate from -2 to 2, and the function is equal 5. When you square it will be 25 with delta t. So you have 1 over 8, integration of 25 will be 25t, and the limit from -2 to +2. You have 25 over 8, and t, you substitute 1 time by 2, 1 time by -2, so you got 25 over 8 times 4. By 4, 1 by 4 is 2, so 25 over 2. So you got the power equal to 25 5 over 2, which is equal to 12.5. So you ask, question, if the power has a finite value or not? Yes, of course, it has a finite value. So it is a power signal. That's a power signal. Well, that's the last example in continuous time signal. Let's say x of t is equal 4, something like that. Constant. So the magnitude will be the same, and then you square it will be 16. To find the energy will be the integration from minus infinity to infinity. X squared would be like 16 dt. Obviously that will be infinity, because you'll have, let me make it a little bit clear for you, 16t and t from infinity to minus infinity, so it be infinity. When you substitute t by infinity, 16 times infinity is infinity. So it's not working. So it's not an energy signal. Maybe it's power, maybe it's not. So I have to use the power. What is the formula for power? Power, we say that we're going to integrate from minus t over 2 to t over 2, 1 over t. The same thing here. The signal is squared, integrated, but we found the limit when t goes to infinity. So you have the limit 1 over t, negative t over 2, positive t over 2, and the signal square we found is equal to 16 dt. Oh, it's easy to integrate. So it will be the limit when t goes to infinity, 1 over t, and the integration will be 16 t, and the limit from negative t over 2 to positive t over 2. So will be equal the limit 1 over t and 16 t, substitute one time, t over 2 minus negative t over 2 equal to limit 1 over t, the limit when t goes to infinity. You have 16, and then t over 2 minus minus will be plus, so it will be t. So t cancel with t, so the limit of 16 is 16. Yes, the power is limited, is less than infinity. That was the power expression. So the power is equal to 16, which is less than infinity. It is a power signal. By this example, we finished explaining the energy and power signal in continuous time signal. And next video is going to be energy and power signals for discrete time